webcast is now starting. All attendees are in listen-only mode.
Good afternoon, everybody. I want to thank everyone for joining us today for this web event brought to you by StarWind Software. Today's event is going to focus on Hyper-V and high availability storage, specifically using the StarWind iSCSI product and the new high availability offering. My name is Bob Boulay. I'm one of the senior solution engineers here with StarWind. I primarily cover the U.S., generally North America, South America, this side of the world. I'm also joined by Dmitry Klemenko. He's also a senior solution engineer here with StarWind. He actually covers the rest of the world. Dmitry, do you want to go ahead and introduce yourself?
Good afternoon, ladies and gentlemen. I welcome you here at our webinar. I am the storage solution engineer, as Bob said, for the European, Asian, and Pacific markets. And I will be helping you in your cases with our software. So after the webinar, should you need any assistance with your cases or with the customers, I'm the one who will be helping you. And today's webinar will be broadcasted to you by Bob Boulay, my colleague from US. Thank you.
Excellent. Thanks, Dmitry. All right, guys. So today's session, just so you get a sense for what we're going to do, and let me go ahead and bring up the dreaded agenda slide here, so everybody can get a quick look at sort of what's going to happen next. We're going to talk a little bit about an overview of SAN technology, discussing traditional fiber channel SANs along with iSCSI, SAN versus direct attached storage, some of the benefits and why you want to consider SAN technology outside of just the need for shared storage and creating things like a Windows cluster to support your Hyper-V environment. And really, sort of roll up our sleeves and talk a little bit about why you should consider iSCSI as an option for that. And then we're going to get into the sort of the meat of the presentation, which is really why I'm sure a lot of you are here. So a lot of you probably have downloaded the white paper that's out on our site, written by Russ Kaufman, one of the Microsoft MVPs that I work very closely with, with regards to setting up a clustered environment to support the Hyper-V environment. So we're really going to jump right into that piece of it, and really start talking about things like shared storage requirements, Hyper-V, a real short overview. Talk about storage high availability to sort of mirror the high availability that you've got at the application level by creating a Windows cluster and basically running your VMs within that Windows cluster. How do you back end that with the same amount of uptime or the same amount of availability using StarWind HA? Talk to you a little bit about things like clustered shared volumes. Again, all covered in great detail in the white paper. So we're going to touch on all of that. And then ultimately, once I've gotten through those PowerPoint slides, we're actually going to go over to a live demo portion, so where I'm going to actually show you the creation of highly available storage and then bring you over to an actual working cluster and show you how to connect that storage using the Microsoft NPIO drivers to your high availability cluster, and then actually show you virtual machines and a couple of the really nice features of 2008 R2 as it pertains to Hyper-V and the ability to do things like live migrate and some of the real benefits behind things like clustered shared volumes. Now, just so everybody understands, this is really meant to be an overview. Obviously the details are in the white paper. The other thing I'll mention is that Dmitry and myself do make ourselves available on a regular basis to users, customers, folks that are considering this type of setup to do sort of one-on-one sessions as well. So, if you come away from this event, not having seen something that you were hoping to, don't despair. Certainly you can, follow up with us one-on-one, and we're happy to go ahead and actually do a private session for you in your own environment and actually walk you through this as well. There will also be a Q&A section toward the end, and essentially what I'll say is I never have enough time to get to everybody's questions, but if you type them into the user interface via GoToWebinar, that records the question, and the commitment that Dimitri and I will make is that if we don't get to your question live, we will certainly get to it as a follow-up, so you'll hear from us afterwards. And the other bit that I want to mention is this session is being recorded as well, so we'll make this available for download via our website. We'll also set it up so that you can get a copy of the PowerPoint if you so desire as well. Okay, with that said, we can really sort of start diving into the meat of the presentation here. I always like to start these sessions, and for those of you that have heard me speak in the past, with sort of a baseline around what a traditional fiber channel SAN looks like, and really sort of set a baseline around sort of what's out there, what's been tried and true in the past, and what a lot of you have either considered or maybe are using at this particular point. Obviously, with fiber channel, and the idea of a SAN is that you're separating out that storage layer from the application layer within your environment. So you're essentially taking that first step of managing storage as a separate entity within your IT infrastructure. And really, the benefits there, and we're going to talk about these a little bit later on, but really the benefits there, are many in terms of, not having to worry about managing storage from, 3, 4, 5, 10, 15 boxes, and really being able to simply go ahead and manage storage and parse out storage as it's needed to your application servers. And for a lot of you, that now includes, that virtualization piece. So whether you're, chosen Hyper-V, which is what we're going to really focus on today, or if you're an ESX shop or a Zen shop, really looking at the flexibility that separating out the storage from that application layer provides you is critical. Now, one of the things that I do like to point out here, and those of you that are using this type of technology understand this, fiber channel is extremely fast, extremely reliable, a very good technology. The downside for a lot of folks is it's very expensive. We're really talking about proprietary equipment, proprietary networking, HBAs, specific HBAs that need to go into those application servers or those virtualization hosts. And then, black box type of scenarios at the storage level. So while this option is, again, reliable, tried and true, has been around for a long time, is not always possible. And that's really where, the iSCSI market has really sprung up, and to provide folks with an alternative, providing you with the same level of performance or close to the same level of performance, depending on how you architect this, but doing it at a cost and at an entry point that's not prohibitive to most folks. And so that's really what I want to talk a little bit about today is really the alternatives to the traditional fiber channel SAN. Now, the flip side of that, obviously, is the iSCSI SAN. Now, this is a very, very rudimentary overview, of a basic iSCSI. Now, you're going to notice it looks very, very similar. And you're talking about, again, really sort of networking to get access to the storage from the application layer. The difference here in this case is we're talking about commodity hardware. So we're talking about things that are non-proprietary, equipment that you either have in your shop or are familiar with how to administer, how to set up. It does not require, additional skills or to go out and hire, say a quote storage specialist. These are all things that you can generally set up, configure, and maintain with the current staff that you have. And so, you combine that with the idea that, everything you're looking at here is all sort of off-the-shelf commodity hardware. It really makes for, a much lower barrier to entry here in terms of getting into shared storage. Now, as you can see there, one of the things that you do have to consider, obviously, is it's still going to require things like dedicated networking. The only difference is that instead of proprietary equipment or specialized equipment, I can use an off-the-shelf switch. I can use off-the-shelf NIC cards. If I really want to, I can spend some extra dollars and get an iSCSI HBA. But really, I can certainly go through the process of just using off-the-shelf network adapters. And then my iSCSI boxes, really, again, I can contact my Dell, my HP rep, or I can. The beauty of this is I can even repurpose. A lot of you may be going through a server consolidation process where you've got hardware that's still in service. You still have a warranty on it. It's still usable. It's got solid drives in it. You can certainly go through the process of simply setting those boxes up as part of your iSCSI SAN and serving up the storage within those boxes using something like the StarWind storage virtualization technology. So again, the benefits of shared storage, getting into shared storage, but doing it at a lower cost point, reducing some of those barriers to entry around that initial budget hit that you might take, with some of the more expensive options out there, and really being able to go through the process of constructing and maintaining something like this on your own. Now, the question always comes up, and when we start to talk about, shared storage and, why should I consider it? I've been running on direct attached for a long time, and, it seems to have worked well for me. I think that, when we start talking about, and it's obviously a no-brainer when we talk about things like clustering, being able to, whether you're using Hyper-V or you're using another virtualization solution, all of those enterprise features that are associated with failover, fault tolerance, and load balancing all require shared storage. But really, taking a closer look, at a SAN implementation, and really, talking a little bit about why would you consider separating that storage layer out from that application layer? Obviously, the central management of storage resources really does make life a lot easier if you really get through the initial setup, get everything running. You're in a point now where you don't have to worry about managing storage on 10, 15, 20 servers. You're just managing a central pool of storage and parsing that storage out to those servers as it's needed. When you add storage virtualization into the mix, which we're going to talk a little bit about today and really get into the details around that with, say, a product like StarWind, you really gain a lot of flexibility in terms of the way you're going to manage, purchase your storage, and the efficiencies that go along with being able to manage a pool of storage and hand that out as it's needed, as opposed to worrying about, do I need to add a storage cabinet to this server or that server, and, am I running out of slots? Am I running out of, do I need to add additional drives to, server A? Is that going to create some waste? So really the efficiencies that go along with that. And then we talk about, sort of managing storage as a separate entity in the data level or the block level protection strategies. Now you're able to go ahead and mirror those volumes at the block level, or do volume-based snapshots, and really protect this data and implement some of the strategies around protecting the data at the storage level, as opposed to having to go through and, say, set up replication at your application level. Doing it at the storage level tends to be more efficient, tends to be, you can do it at a LUN level or a storage pool level, as opposed to, in the database world, maybe replicating each individual database and having to manage the replication jobs that go along with every single database. You can simply replicate the volume that is serving those databases and ultimately have a block level copy there. So, a lot of data level protection strategies that go along with, considering or go along with the central management of storage, as opposed to, that sort of distributed approach where you have storage associated with each individual box. And then obviously, the unlocking of the application enterprise features, this is never been clearer than with, the virtualization movement. Obviously things like Hyper-V and setting up a cluster like we're going to talk about today requires that shared storage, and that really gives you the ability to set up fault tolerance amongst those virtual machines. So a lot of those enterprise class features are unlocked, whether you're using Hyper-V, VMware, or Xen, are unlocked by the use of the shared storage architecture or that sort of centralized storage, so that you can set up fault tolerance. You can do things like load balance, live migration, all the things that you need to do to get to the uptime numbers that are being required of you generally when you start going into a project like this. And then obviously no shared storage equals no cluster, no VM failover. I mean, it's that simple. It's, you know, one of those situations where if you want to be able to, you know, create a scenario where if you lose a host, those virtual machines continue to remain up, this is a requirement. And so we have to consider this. We have to consider that central storage model, and really all that's left is trying to figure out the best way to do it and how to fit it into a budget. So the next thing I want to chat a little bit about is why you should consider iSCSI. I'm from StarWind. The slide says StarWind, but really, you know, talking about just iSCSI in general and why you should consider it. I like to talk to folks, about, going through a process like this and really sort of making some decisions around sort of the technology that's going to work for them. The nice part about iSCSI, and you've heard me say it, and it'll be a reoccurring theme throughout all the presentations that I do this year, is really the ability to set this up on commodity hardware. So, non-proprietary technology that you are familiar and comfortable with, you're able to set up and administer. It does not require an army of consultants to come in. Of course, you require support. And of course, you require some help sort of maybe with the initial setup. But I think that all comes with, choosing the right vendor. I think it goes back to, the ability to go ahead and get something like this off the ground for an affordable price point. In some cases, repurposing maybe some hardware that you've got left over from a server consolidation. But in other areas, being able to simply go out and maybe purchase a new server and, go ahead and set this up, or a pair of new servers. But it's off-the-shelf stuff. It's stuff that you're familiar with, you understand. It's easy for you to go ahead and you can save dollars by configuring these things on your own. So really, and I think the last bullet there says it all: reliable, scalable, fast, and ultimately affordable is really the trick here when we talk about iSCSI. Now, and for some of you this may be, a little too much, sort of review, and so I apologize for that. But for those of you that are sort of new to the arena, talking about, what is iSCSI, we're talking about, traditional SCSI disk commands transmitted via the TCP/IP stack. So again, much like, a fiber channel SAN, we're talking about networking the storage and issuing those block-level commands, via the TCP/IP stack down to the storage layer. Obviously, for most of us, this is going to require things like dedicated networking. So if you picture a scenario where you've got, a bare bones type of setup where you have maybe one NIC to service the application out to the corporate LAN, one NIC dedicated for just that iSCSI traffic. Obviously, it gets a little bit more complicated than that in environments where you're in production, but certainly at a minimum, that's what we're talking about. Interacting with the TCP/IP stack to issue those commands to the remote disks. It doesn't get any simpler than that. And so you can understand, and obviously utilizing the initiators to interact with the iSCSI target, if you will. And we're gonna get into a little bit more detail when we look at the live cluster, but using things like the Microsoft initiator, the Microsoft iSCSI initiator in a Hyper-V environment, or the initiators built into Xen or built into ESX, in those types of environments. iSCSI service is running on the storage server. So, essentially what you're going to do is there will be a service running on that storage server that's going to export the disk. In our case, it's either a physical target, so you could take a RAID set that you've created on your box, simply pass it through as a target, or you can use storage virtualization to actually carve that up into different, that physical disk into different pools of storage. And those different pools of storage can be highly available, or can be snapshot enabled, or can be asynchronously mirrored. And again, we talk about running on commodity hardware. There's that common theme again. A traditional IP network, off-the-shelf server equipment, and all the benefits of running a SAN or that storage area network and centralizing your storage without the large upfront costs. Some of the benefits, again, when we talk about iSCSI, familiar networking standards, and for a lot of us, this is really what makes it simple to go ahead and set up, and that we don't have to worry about proprietary hardware from that sense. I put a bullet in here, we'll scale to 10 gigabit Ethernet. Those of you that are considering that, those of you that are looking at it, as the equipment that surrounds that starts to become more affordable, I run into the occasional customer with a 10 gig backbone, but most of you are still on gigabit Ethernet, which is fine. It works just fine. We've got some optimization steps that you can take, and certainly that's something that either myself or Dimitri can talk to you about one-on-one. Replication for protection, or other protection features without the cost. Again, we're talking about, commodity hardware here. So if I want to set up a DR site to replicate to, I don't have to go out and buy two $30,000 SANs. I can, maybe spend my money, the majority of my budget on the primary, and then go out and buy, different hardware, maybe less expensive hardware for my failover site. I can mix and match that hardware. Eliminate the cost of overhead for proprietary hardware, and then ultimately will fit into things like mixed environments. So for those of you that maybe already own a fiber channel SAN, consider this when you start looking at maybe tiered storage. Is there things on that fiber channel SAN that don't need to be there? Can you go ahead and maybe implement an iSCSI SAN and move some maybe tier 2 or tier 3 stuff onto that? So obviously a lot of flexibility and a lot of options there. Performance best practices, and again, this is sort of the build-up, assuming that a lot of you will be looking to implement this with a Hyper-V cluster. So just a build-up and a review of some of the performance best practices. Obviously, network isolation. When we look at a couple of the videos that we've put together for this PowerPoint, we'll really talk in more detail about that network isolation. Network optimization, doing things like enabling jumbo frames and optimizing the TCP/IP window size via some registry changes that we can offer. And then ultimately, matching disk speeds with I/O loads. I mean, this is really a very, very important part of the performance of any storage, but certainly as it relates to central storage management, you want to make sure that you're matching one for one the performance that's required by the application with, the underlying disk that can deliver that performance. And so, the configuration of your RAID sets is key. So choosing the type of RAID set that you're going to set up within the storage boxes. Using proper disk, that'll drive the level of performance that you're looking for. And obviously, this is always a trade-off between the cost and the performance that you're going to get. And then obviously RAID sets with I/O patterns. And I like to talk to folks about this, in terms of things like as simple as, avoiding, the I/O patterns that are more random with the I/O patterns that are more sequential, sharing the same set of spindles. Something that rudimentary can really impact performance, and it's something to consider when you start to plan out which pieces of storage are going to service which application servers. And then finally, the monitoring. So you want to make sure that, this isn't just to set it up and walk away from it. It's like any other, sort of aspect of your IT environment. Monitoring is critical. Monitoring things like disk performance, disk queue lengths, and disk can quickly become the bottleneck if, these things are just sort of loaded up and loaded up and loaded up. Without anybody stopping and taking a look at, well, what's the situation with this RAID set, or what's the situation with this given set of spindles? Do we need to adjust? Do we need to spread the load out a little bit? So, again, very, very important. And then the data protection pieces, as I mentioned earlier, block level replication, whether that be synchronous via our HA model or asynchronous. So if you want to replicate data at the block level down to a DR site and create exact replicas of your volumes at a DR site, or if you're already somebody that's, say, working with data protection manager or something like Veeam in the VMware world, where you're creating a replica of your site over at a DR location. This is a nice cost-effective way to bring in a SAN and service that DR location through that block level replication. Point-in-time snapshots. Again, doing things like taking and capturing deltas on a set time frame so that you have rollback points at the volume level. So, much more efficient in that we're just looking at or evaluating the volume and capturing those block level changes to create that point-in-time snapshot of a volume. And then doing things like securing your storage, so CHAP authentication, IPsec, run masking, making sure that, only certain servers or only certain users have access to certain pieces of storage. And then obviously high availability, a storage cluster, which we're going to talk about today, via MPIO. So I want to transition now into from something that's maybe a little bit more generic around storage into sort of the Hyper-V scenario at this point. And this diagram we'll spend some time on, and this is sort of what a basic implementation might look like. Again, very rudimentary. This isn't anything that's very complex, and I've really sort of stripped away a lot of the complexity just to make sure that everyone understands sort of what it is that I'm trying to convey here. So, some of you may be looking at this and going, well, gee, I wouldn't architect my environment like this. I'd add a redundant switch or whatnot. Absolutely, and certainly the purpose of this is to sort of keep it nice and simple so that we can walk through some of the key components. Obviously, from a networking perspective, we talked a lot about sort of network isolation. Now, what you'll notice is, I've got my Hyper-V nodes here, and I'll have, from a software perspective, set these up in a cluster. But before I do that, obviously, I want to go over to my shared storage nodes and create the shared storage that's going to actually support this cluster. And so as you can see here, I've got, in an HA setup, my two StarWind nodes. Now, what this looks like, as you can see here in red, I've got my, and I apologize if you can't see this very well, and I'll certainly get this presentation out to everybody as well. But in red here, I've got what represents the routing for my iSCSI traffic. So I've got that running through, a Gigabit switch here. In this case here, I've got a two-node SAN that I've got set up as a highly available SAN. So basically, I've got automated failover here via MPIO. And we're going to, the next couple of slides, we're going to blow this up and actually show you, what that looks like in detail from the storage level. And as you'll notice here, I've got a blue synchronization channel here. This is obviously key for, and we'll get into a little bit more detail in just a moment, but that's key for the high availability storage. And generally speaking, you can route that through your switch, or in this case here, as I'm representing, simply use a crossover cable to go ahead and create that synchronization channel for your StarWind HA boxes. But as you can see here, I've got, routing for, through dedicated networking for my storage. So each one of these Hyper-V nodes has access to the shared storage that's served up via iSCSI through a dedicated switch. Then I've got my my general corporate network. So this is, these application servers that are being hosted on these Hyper-V nodes obviously need access to the rest of the world. So users need to interact with them, whether it be a VDI type of implementation or a SQL server or some type of application server that you're serving up. So obviously we're segregating out those elements here and networking that out to an interface to the corporate LAN and then out that way to the user network. And then obviously a heartbeat network or a private network that's utilized to go ahead and link up all of the Hyper-V nodes to be able to do things like, serve as a network interface for things like live migration and really sort of go through the process of making sure that each node knows when the other node has died. So that sort of heartbeat network that you're all familiar with when it comes to sort of general, Windows networking or Windows clustering. Again, and as you can see here, what I've done here is and we're going to talk in a little bit more detail about these as well. I've set these up as clustered shared volumes, and so you can see here I've got, clustered shared volumes with mount points to each one of these clustered shared volumes on each one of these Hyper-V nodes. And so this is really the basics of what this is going to look like when all is said and done. And again, I mentioned the basics. Obviously, there's a number of levels of complexity here with regards to hardware redundancies and best practices that we can cover on a one-on-one basis. But I think you see the sort of bare bones of what this is going to look like. And obviously, as you can imagine, as you add VMs to your Hyper-V environment and assign them to the various nodes or load balance them across these nodes, if a node were to fail on this end, those virtual machines would then fail over to another node in the cluster. The same goes for your storage. And that's really where, when we talk about the title of the webinar and start really talking about high availability storage with a Hyper-V environment, we're talking about the ability to go ahead and have, through the MPIO driver within Microsoft, the ability for these servers to issue simultaneous writes to both of these servers with a synchronization channel in between. So that if you were to lose one of these servers, or if you were to, because the storage is hosted via Windows, if you need to bring one of these boxes down for patching, or to apply updates or to add additional drives to, you can do that without fear of losing your cluster, losing access to its storage. And so, a very, very important type of scenario, because why go through all this of creating this cluster if you simply end up with a single point of failure on your storage? And that's really what we want to stress today, is the ability to go ahead and eliminate that single point of failure that may exist via your storage. So, one of the things that I want to do is I want to take a closer look at, the clustered shared volumes. And let me just bear with me for a second here. I think I skipped one. Yeah, there we go. Let's start with actually the storage clustering before we get into the clustered shared volumes. And, this is a bit of a blow-up of the diagram that we were looking at earlier with regards to the MPIO and the utilizing the MPIO driver, which I'm actually going to show you that live in action here in just a few minutes. But ultimately, we're talking about, as you can see here, iSCSI node 1, iSCSI node 2. In this case here, I'm representing a crossover cable as the synchronization channel between these two. And then ultimately, again, I've set these up so that you can visualize this redundant path. So a lot of times what people will do is they'll go ahead and, for the purposes of fault tolerance, they'll team maybe some NICs together so that they get, no single point of failure from the perspective of, the NICs that are in that box as it relates to connecting to the storage. You can take that to the nth degree as well and then actually create redundant switches and really create two redundant paths. But really what's important to note here, in this scenario, and as you're going to see during the live demo portion, we've got a situation where the initiating node is actually simultaneously writing to both clusters, so both storage boxes, by using the MPIO driver. And then obviously those boxes are staying in sync through that synchronization channel. What that does, and so there's traditionally been a couple of ways to create highly available storage in the iSCSI market. One of them was, in the initial scenario, was to take your, if you're running under Windows, take that storage service, that iSCSI service, and basically create it as a clustered resource. As you know, there are some pitfalls to that. Obviously, the failover, while it's relatively fast, does take some time and presents the opportunity there for a timeout with regard to the storage, a loss of connectivity to the storage. So what StarWind has done is ultimately said, okay, well, we're going to eliminate that process, and we're just going to utilize that MPIO driver and write simultaneously to both nodes, so that if one of these nodes were to die, the I/O would continue to be serviced through the second node, or if the second node were to die, it will continue to be serviced through the first node. So it doesn't really matter which one of these nodes dies. The storage will not be disconnected from the cluster itself. It will continue to function normally. And then, as you're going to see in the demo, we've got a process that allows you to bring that storage back up if you've brought one node down, and then ultimately synchronize it with the node that's continued to service the I/O. So that's really a sense for what that looks like and how that works from an I/O perspective and from sort of a redundant storage perspective. And then the other thing I wanted to talk a little bit about before we dive into the live demo is the clustered shared volumes. And this is a really nice feature, in 2008 R2. And for those of you that use some of the early versions of Hyper-V and the pre-R2 stuff, you'll know exactly what it is that I'm talking about. So under those initial versions, what was required was to create a disk resource, and that disk resource could only be owned. That is, the I/O could only come from a single node in the cluster. Now, if that node failed, another cluster node would take ownership of it. What that resulted in is, you had to basically group your VMs, according to, a volume itself, a physical volume. That volume may be owned by, Hyper-V node 1, and if you wanted to fail that over, all the VMs that were on that volume had to move over. So if you wanted to migrate from node 1 to node 2, you had to migrate ownership of that volume. With clustered shared volumes, it becomes much easier to sort of load balance, in that what you'll find is that each node has I/O access to the clustered shared volume. Very, very easy. It gets us a little closer to that clustered file system that you see with VMFS. And ultimately, this is accomplished, and I certainly don't purport to know all the details in terms of exactly how Microsoft did it, but certainly what you'll see when you set this up, when you create a clustered shared volume, which we'll actually show you today, is you'll see a mount point for each one of those volumes on each node in the cluster. And so ultimately, you can now go ahead and create a large volume, create multiple VMs on that volume, and then ultimately spread the VM load out across multiple nodes in the cluster without having to assign the volume to a specific node in the cluster. So again, a lot more flexibility added as it relates to the ability to load balance across different servers in your Hyper-V environment. So a very exciting release as part of the R2 release with Hyper-V, and I think it's something that really brings Hyper-V that much closer to a solution that can really be utilized in the mainstream and challenge some of the other vendors out there that are doing similar things. Again, this is all back-ended by iSCSI, so you're basically connecting or taking that iSCSI data store. As you can see here, I've got representation of all my VHD files. Here, and ultimately those iSCSI data stores are being basically set up as clustered shared volumes. So you get that central storage, you get the ability to go ahead and do read-write I/O from any node in the cluster to that clustered shared volume without any risk of corruption or conflict. So what I want to do now is jump into the live demo portion of today and really give you sort of a brief background on, starting from the storage level, how to create some highly available shared storage. And then we'll go over to a cluster and actually look at the connections that are made from the cluster to the shared storage, actually show you some of those virtual machines that are running on that shared storage and so forth. So let me go ahead and dive right into that. Now, let me log in here. What I've done here in terms of showing the flexibility of a solution like this and the ability to do things like storage virtualization is I've got a 2003 server here, which is the server that we're on now, which is my the local host here, and I've actually partnered it up with a 2008 core box that I'm running for the shared storage purposes. And I've got completely different disk drives, completely different hardware here, and really it's all normalized via sort of the storage virtualization piece that you're going to see. Now, as you see here, I've got a couple of pieces of highly available storage already set up that are servicing my cluster. And I'm going to go ahead and walk you through how to set one of these up now. So I'll set up a test piece of storage, and then we'll go over to the cluster, and we'll look sort of at how it's all connected. So to start, I'm going to go ahead and add a target here. Now, of course, the background behind all this is I've essentially gone through the process of installing an OS on this box. I've taken the rest of the drives in this box, and I've configured them based on the RAID set that I need to support my environment. A lot of you use RAID 5, RAID 6, or if you have some additional disks in that box, or you've got maybe a storage cabinet attached to that box, maybe set up a RAID 10. But you're basically going ahead and setting up that storage and presenting it to the operating system. And then from here, you simply go ahead and install the StarWind SAN target software. You go through the process of then, once that's done, setting up or deciding on sort of how you want to present that storage to the iSCSI network. In this case here, you're going to go ahead and click Add a Target, and then go ahead and give it a name. Test HA Demo 1. You're going to actually select the storage type. Now, for those of you that aren't familiar with StarWind at all, obviously you get the option of actually sharing out hard drive space, optical drives, for those of you that are looking for a backup solution. We allow you to actually pass through as an iSCSI target a tape device. We also offer a virtual tape device, which is going to be the subject of an upcoming webinar as well. In this case, I'm going to choose hard disk. And then I get to choose, how do I want to pass this storage through? Now, I've got the option of creating a physical iSCSI target, which I'd simply go ahead and select the appropriate RAID array that I've formatted and configured in my storage box, and pass that on through if I wanted to make a standalone target. Or I've got the storage virtualization options. Now, I'm going to choose Advanced Virtual. And for the purposes of today's session, we're going to focus on the highly available device. Now, as soon as I choose that, the first thing it's going to ask me for is what's the IP address of the host that's going to serve as the partner server in this HA setup. And so we'll go ahead and plug that in. And then I need the username and password for the service. And click Next. Oops. Let's try this one. 160.1.151. Doesn't seem to want to accept that, so let's try it from here. HA. We'll go with hard disk, advanced virtual, and high availability. And we'll say all right. Well, obviously, being in a lab environment, it's not functioning the way I'd hoped. So let's pop over to one of the other boxes here and give this one a shot. We'll come over here. I've actually got iSCSI running here as well. And we'll do it here. So, do test HA1. I'm sure those of you that have done live demos in the past can sympathize. And then let's try the 151. There we go. So as soon as I typed in that IP address of that partner server, it went out, made sure that the service was there, the service was indeed running. And then ultimately it's now going to go ahead and tell me that it's going to set up a target on that partner server, in which case here it's just going to call it test HA1 partner. Now again, what it's doing is it's setting up target A and target B, which ultimately will make up this HA set. So again, very, very straightforward in terms of that. Now it's also going to ask me for the virtual disk parameters. Now this is really where, being storage virtualization, I'm going to go out and I'm going to choose a physical set of storage on both my current server and on the partner server where I want to create this. So I'm going to create a couple of new image file devices. And as you can see here, it's telling me, okay, where do you want to create this? On which disk drive do you want to create this? And we'll call this test HA Jan 27. And we'll do the same thing here on the partner server. And again, it's going to ask me where I want to create it. And I'll go ahead and create a small one for 100 megabytes. And then the next piece it's going to ask me, and it's going to review sort of what I've got going on here. Here's the fully qualified name for the two targets. And then ultimately it's going to ask me which interface do I want to use as a synchronization channel. And so this is obviously going to be a critical piece of setting up your highly available storage. You need to have that synchronization channel in between. Now, what I do with most customers is I walk them through the process of actually setting up a crossover cable between these two. If you choose to route them, I tend to, or run them through a switch, I tend to recommend, a NIC team so that you don't wind up in a situation where you lose synchronization. Losing synchronization obviously is not a good thing in that it's going to result in the storage not being available. So this is a very critical part of the storage, the highly available storage here. So I can go ahead and set that up next. And then I'm also offered the ability to go ahead and actually either clear the mirrors or go through a synchronization process. So if any of you that are using maybe our free product or have used maybe a different version of our product, you can go through the process of taking an existing image file and converting it into a highly available storage device without a lot of work. It's very, very simple. You just go ahead and select that existing image file, create a new one on your partner server, and then choose the synchronization path that you want to go down. So do you want to go through the process of actually synchronizing data from server A to server B? So again, very, very simple to go ahead and do that. Now, before I go through this process, let me bring you back over to here. Now, as you can see, I've got a couple of pieces of shared storage that have been set up to service my cluster. So again, very, very straightforward from that perspective. I've gone through and just done this process 3 times. In a 2-node cluster, I've created a quorum drive, and I've created a couple of small data stores that are going to go ahead and service my cluster. Now, my cluster is over here. And let me bring up the cluster failover manager. So there's my cluster failover manager there. There's a couple of VMs I've got running on there. There's my storage. And my storage ultimately is going to allow me to go through the process of, being able to have that shared storage and actually create the cluster. It's going to go through and look for that storage. But more importantly, one of the things you want to do as you go through the process of creating this is go through and make sure you understand from the initiator perspective exactly how to go through and connect this storage to both nodes. So really the steps in this process are to go ahead and install the OS on your Hyper-V nodes, install the Hyper-V role along with the MPIO role. And so, one of the things that's often overlooked here when you're using highly available storage is to go through the process of installing the MPIO role, the MPIO feature here as well, so that you can take advantage of multiple paths to the storage. And as you can see here, what I've also done is simply plugged in the IP address under the discovery for the various targets that are going to make up my HA devices. So again, very, very straightforward here in terms of doing that. Simply plugging those in and discovering those targets. And, it makes it very simple when you do that. And as you can see here, what the StarWind service is doing is taking that device, and once you've connected to it from both nodes, so I've got my quorum and my quorum partner here, and I'm connected to both of them. If I look at the device properties here under MPIO, you can see I've got a .80 path to the storage and a .202 path to the storage. So I've got my multi-path storage set up so that if I were to lose one of these storage boxes, if somebody kicks the plug out, if I have to go ahead and do a Windows update on one of these storage boxes, it's very, very simple to go through the process of just continuing to write to whichever one of these is still alive. So again, very, very easy to set up. Now from the the clustering perspective, in terms of how to go about doing that, obviously the first step is going to be to install your OSs, install the Hyper-V role, the failover cluster role, and then connect up to your storage, and then actually create your cluster. While you create your cluster, it'll go out and do a series of validation steps that will look at the storage that's available, make sure that you're connected there, and obviously you want to make sure that you've connected the storage, you've formatted the drives from all nodes in the cluster before you go ahead and proceed. Now, once that's done, this is sort of the end result of that. And for anybody that is interested in sort of the step-by-steps, we simply didn't have time to fit it into today's session, but we've got a couple of videos out on our site that walk you through setting up a cluster, and also are happy to go through the process of working with you directly on doing that as well. But this is ultimately the end result. And as you can see here, I've got, from a storage perspective, I've got my Quorum drive and I've got my 2 clustered shared volumes. I've got my multiple nodes here, all connected up to my highly available iSCSI backend, where, if I were to lose one of these nodes, I simply will continue on from a storage perspective. So I could come in here and, maybe this is the best way I know how to show you. I know some of you will say, well, this is kind of an elegant shutdown, but certainly you're happy or welcome to set this up and go through the process of just yanking the plug. If I were to go ahead and lose one of these storage nodes like I'm doing here, it's going to go ahead and we'll let the service terminate here, make sure it's down. And so we've lost connectivity to the storage server on this box. My storage will continue to remain available to me from the cluster itself. And as you can see, via the iSCSI initiator, it will catch up here. It'll say reconnecting on the partner server while the storage remains available. And as you can see here, my Hyper-V machines stay up, continue to be running. My storage continues to be available to the cluster. My cluster shared volumes remain online, even though I've lost one of the nodes of my storage, my iSCSI storage. So again, very, very easy to go ahead and set up and really sort of mirror that high availability that you're looking for at the application level and relate that back to the storage level. And then obviously some of the other options you have here are things like doing things like live migrations. So, being able to migrate a virtual machine. And this is all covered in the white paper. I've got these machines on clustered shared volumes so I can move them around from one storage or from one node to the next. So if I could simply do a live migration here and it would go ahead and live migrate that over to a different virtual or a different node in my cluster, moving everything over and then running that virtual machine off of that second node. So again, very, very straightforward in terms of setting something like this up, getting to a point where you've got, the fault tolerance that you need at the VM level. So the other nice part is if I were to shut one of these boxes down, it's very, very simple to go through the process of just watching all your VMs fail over to, another node in your cluster. So, again, providing that fault tolerance, that high availability at both ends of the spectrum, without having to worry about, is losing one server going to cause me all sorts of issues? So back to, sort of the wrap-up here, and I think that one of the things that I want to do is I want to leave a little time. I'm looking at the clock here for some Q&A. So I want to sort of dive into the Q&A portion here, and let me go ahead and see if we've got any questions here. It looks like we've got about 10 questions. Continue to go ahead and type in your questions, and like I said, if I don't get to them, I'll certainly make sure we follow up with you. If you want to see this in a little bit more detail, because we only did have the hour today, we're certainly happy to go through the process of demoing this for you one-on-one as well. So this is also an option. So let me take a look at what we have for questions here and see if we can get to a couple of them. First off, will this be available for download at a later date? Absolutely. I am recording this session, so we will make it available. Next question, what about performance on a 10 gigabit network? Absolutely. As I had mentioned earlier, you're going to see scalability of this up to 10 gigabit networking. We've tested with it. We work with it. So if you've got a situation where you require a larger pipe, if you've got a very transactional type of virtual machines that you're running that are very I/O intensive, having that available to you from that perspective is going to make it very, very simple to go through that process and simply connect a larger pipe or connect that 10 gigabit backbone to this and then see the performance gains that you're going to get from that. I think the key there, though, is obviously making sure that you continue to, as you broaden the pipe that's available for iSCSI, making sure that you obviously match that with regard to the disk performance. And we're also taking some steps right now from an I/O perspective. StarWind is going to be adding things like I/O caching to its highly available device in the very, very short term. So we're going to make it very, very easy to go ahead and really set this up so that you can get the best performance and squeeze the most out of whatever networking you happen to be using. Is there any comparison sheet for fiber channel iSCSI on 1 gigabit iSCSI versus 10 gigabit, etc.? We do have some information that we can provide to you, Martin, and we're certainly willing to work very closely with you. I think that Will Markey is somebody that we'll give a call to and talk to you in a little bit more detail on that offline. Let's see here. Is it possible to have iSCSI traffic and sync channel on the same NIC using a VLAN? It certainly is. Candidly, I don't know that I would recommend that. I think my recommendation to most customers is to go through the process of separating those out. But it is something that you can do, and so it's something that it will work. I find it, from a best practices perspective, to have a separate interface for your synchronization and the traffic that's actually being serviced via iSCSI. Can I use two-switch scenario for iSCSI network as a redundancy? Absolutely. As I've said, I think that we could all agree that the diagrams that I used here are somewhat rudimentary, and I do that on purpose only because it's hard to know sort of who's in the audience, and so I like to make sure that everybody understands sort of what is available and sort of what the basics look like. But certainly you can do that. You could, create redundancy at the NIC level and at the switch level so that you have, fully redundant paths to the storage. Let's see here. What is MPIO? That is simply a multipath I/O. Most of the vendors, when it comes to virtualization or iSCSI initiators, have developed their own sort of MPIO drivers. For the Microsoft perspective, they offer that multipath I/O so that you can simultaneously, if you're using a highly available storage device, issue writes simultaneously to 2 nodes of storage, or if you simply want to create NIC redundancy there, you can certainly do that with MPIO as well. Does StarWind replicate over a WAN? We absolutely can. One of the nice things about this is that, as I'd mentioned, we do offer the synchronous mirroring, which is our HA. We also offer, you can run this in an async mode over a slower connection so that you can replicate data over a WAN to a DR site. And that's something that, Lee, I'm sure that Dimitri can get in contact with you and ultimately show you a short demo and a setup of how that works. Let's see here. Just scrolling through here for the next question. Do you need some special hardware in order to enable jumbo frames and TCP offloading? Right now we're having some issues with G4s, G5s, and TCP offloading. That's a question we can take up with you offline. Typically, the TCP offloading is done at the card level, and the driver for that NIC. But that's something we can certainly take up with you offline and talk to you in a little bit more detail about with regard to that. And in terms of the jumbo frames, again, it has to be supported at your NIC level, so you have to have interface cards that support jumbo frames. It also has to be supported at the switch level. So outside of that, as long as it's supported at both those levels and enabled, you're in business. As far as the offloading goes, I think that I'll ask Dimitri to get in touch with you directly, and he'll actually walk you through or actually maybe do a session with you personally that'll actually show you where that, where you might be able to set that up and talk to you a little bit more, about how to get that going, and if indeed your individual NIC card does support it. And just as a recap, guys, just so you know, we are going to be doing a recording of the event. I know someone asked, there's a spot where you can actually view them, but there's no spot where you can download them. I'll get you an answer to that as well, and see if we can make these available for download as well. And then obviously, talk to you a little bit more about, or make sure you get all the information you need. If you need the PowerPoint or whatnot, we can make sure all that's available. So, guys, I think we're just about at the hour here, and now for those of you that have entered questions that did not get answered, please know that we will be answering these on a one-on-one basis. So I'm going to leave the session open for a few more minutes. So if you have additional questions, you can certainly type them in. And we'll certainly go through the process of responding to you on a one-on-one basis. So just because I didn't answer your question here because time didn't permit does not mean you won't get an answer. We'll certainly be following up with each one of you. I want to thank everybody for taking the time. I hope you found the session informative. We do like to do these. We'll be doing another one here on this particular topic a little bit later in the quarter, but we want to make sure that these are informative. So if you've got some feedback for us, you'll be getting a thank you note from our screen share provider. So feel free to respond to that directly. Those responses will come directly to myself and Dimitri. With any feedback, anything that you'd like to see or anything that you didn't see in this session, we try not to make these just strictly a StarWind commercial. We want to make them somewhat educational as well, so we hope we've accomplished that goal. I want to thank, again, everybody for their attendance today. Please do look for this on the site. Within the next couple of days, we'll get this up there in a recording of the session. And you'll also be hearing from us if you've asked a question. Appreciate everybody's time. I hope everyone has a great rest of the day, and thank you very much for your attendance. Take care.